So now we are ready to start to actually name these beautiful things that we've been making, these compounds, and we are now ready to give them formal official names. So in this video and in the rest, actually in the rest of the videos for this chapter, we're going to talk about nomenclature. I would encourage you to have in front of you the basic inorganic nomenclature flowchart that I showed in a previous video, because that has a good summary of all of the rules that are used to name compounds. In my slides that I'll be showing you here, I have used a similar flowchart on how to name compounds, but it's actually from the Intro Chem textbook. I used it in my slides basically because it fits better. But it has the same information, and in fact the flowchart that was given to you in the basic inorganic nomenclature slide a few videos ago, that has more information. But I would encourage you to have that nomenclature flowchart in front of you as we work through the rules in these examples. Because regardless if you use the flowchart portions that I have on my slides from the Intro Chem textbook we have here at Rose, or the inorganic nomenclature flowcharts we use for Chem 1 that I shared in a previous video, both of those flowcharts I think do a good job of organizing the thought process as to what rule is used when. And the first thing you should ask yourself when you're presented with a compound and you have to name it is that you have to determine, is it molecular? Does it only contain nonmetals, or is it ionic? Those things we were just talking about in the previous video. Does it contain a metal and a nonmetal? Once you determine, so now we're first going to talk about ionic compounds, those that have a metal and a nonmetal. Once you determine it's an ionic compound, the next thing you need to determine is you need to look at the metal, the cation, and determine if it is a metal that forms one type of ion or one charge, or if it can possibly form more than one type of ion. How do you know if a metal falls into the one type or more than one type category? The metals that fall into this category, the more than one type of ion, are generally transition metals, those that fall in the middle of the periodic table. Those have a star next to them in one of my previous PowerPoints. Okay. Well, we will talk about those shortly. But let's say you determine that it is a metal that forms just one type of ion, like sodium or calcium. Once you determine that, then you name the molecule by just naming the metal from the name on the periodic table, like sodium or calcium. Then you name the anion or the nonmetal by using the stem of its first name, dropping the INE and add ide. So NaCl would be sodium chloride. CaI2 would be calcium iodide. Okay. So that's how you name ionic compounds, that form just one type of ion. Now you notice there's no mono, dis, and tris. This isn't calcium diiodide. Monos, dis, and tris will only be used for molecular compounds. What if, though, your metal forms more than one type of ion? And as I said, those are listed in a starred chart. It's actually in your MindTap homework and in your MindTap e-text. It's on the previous starred slide in this video series. If you are given a metal that can form more than one charge, there are actually two methods that are used to name that compound. I'm going to introduce both of them, obviously, but I'm only going to test you on the stock system, because that is the system that is most frequently used in laboratory atmospheres and like in research facilities. If you were to purchase a bottle of FeCl3, for example, the label on that bottle would say iron 3 chloride. It would have this stock naming system. It would not say ferric chloride, the classical system. Okay. But I'm not going to test you on the classical system, but I do at least want to mention it. In the classical system, if you have a metal that can form more than one type of ion, then you designate the charge on that ion by either using an us or an ic on the end of that metal's classical name. So you see that, at least with regards to iron and lead, us, the OUS ending is for the ion with the smaller charge. Ic is for the ion with the larger charge. But as I said, the one I'm going to test you on, and the one that is certainly most common, because I think it's a little more easily understood, is this stock system, where instead of using us's and ics, we just designate what the charge is on that metal by using Roman numerals and putting those Roman numerals in parentheses. So for example, in this FeCl3, this is iron 3 chloride. That name automatically tells me that, oh, iron in this molecule has a +3 charge. So hopefully you're asking yourself, well, Mrs. Lapola, how did you know that iron in this molecule has a +3 charge, aside from the fact that I told you here? Well, hopefully, looking at that balanced chemical formula, you would be able to, get my pointer, you would be able to deduce that, oh, the charge on that iron, it would be a +3 because of the charge on chlorine and the rules that we use for writing balanced chemical formulas. What do I mean by that? Let's say I give you this molecule and I ask what the charge of iron is. Don't know what the charge of iron is, but I do know that each chlorine is a -1 charge. It's in group 7. It's a halogen. There's 3 of them in that molecule, right? So I'm going to multiply that by 3. So that part of the molecule is a -3 charge. That part of the molecule contributes a -3 charge. And since the sum of the charges in an ionic compound must be 0, the only way that the charge in this overall molecule can be 0 is if this iron is a +3 charge. So iron 3 chloride. If I had FeCl2, then that would be iron 2 chloride.